think we talked about this, like that the mean and standard deviation give you the best information. Mean for the center, standard deviation for the spread. However, those values are not resistant, so if you have any outliers at all, they are not accurate. And so if your data is skewed, instead you need to go with the median and interquartile range. So I would probably like put a big star next to this or something. It seems like it would be an excellent test question later on. Kind of knowing which measure would be the most accurate in different scenarios. So the last thing that we have to talk about in this is outliers. An outlier is really just a value that doesn't fit in with the rest. And sometimes it's easy to tell and sometimes it's not. You know, if I give a test and everybody scored between an 80 and a 100 and somebody has a 20, does that seem like it would be an outlier? Yeah. Okay, but if everyone got between 80 and 100 and then I had somebody that got a 70, is that low enough to be an outlier? So it's not always just an obvious thing that we look at and know. And there is a calculation to go along with it. Make sure you're kind of looking at your formula sheet as we go through all this. All of these formulas are given, but you need to kind of start familiarizing yourself with where to find them. So we are still in chapter 3, and this is the next to last thing in this right-hand column there. The upper and lower fence. So an upper and lower fence helps us find the outliers. What I would write down, if I were you, you don't have to necessarily do the entire slide. Okay. And this would help us find outliers. The lower fence is the lowest your value can be. The upper fence is the highest it can be. Anything smaller than the lower or greater than the upper is considered an outlier. So we find those and then we look. If it's smaller than the lower fence or bigger than the upper fence, we call it an outlier. So yesterday, our example, we were using those speeds in the construction zone. Let's say I wanted to check that for outliers. So you might have to kind of look back in your notes from yesterday. I think example 3 was the first time we wrote it down. So the lower fence is quartile 1 minus 1.5 times the IQR. And we found when we did this, what was our first quartile from that data? 28. We'll need the third quartile was 38. So what the IQR, remember that's the distance between those, was 10. So we did all of those yesterday. So my lower fence would be 28 minus 1.5 times 10, which is what? What's our, can I adjust something? We did this set of data twice, right? We did it once with the original numbers and then we added in. Let's do it with the one where we added in the point. So remember we had that car going, was it 100 miles an hour or something? That one changed, the IQR changed on that. And did the third quartile change when we added in that point? You guys have that written down from yesterday? We can recalculate it if we needed to. Yeah, because we had these original points, and then we added in the speed of 100. So when we did that, quartile 3 was 39. So then our IQR would have been 11. Let's use that set of data since it actually did have a bigger value. Okay, so if we do that one, we get 11.5. So any speeds lower than 11.5 would be an outlier. Was anyone going less than 11.5 miles per hour? No. So we don't have any outliers in that direction. The upper fence is quartile 3 plus 1.5 times the IQR. So our third quartile was 39 plus 1.5 times 11. And that one we did 55.5. So do we have any outliers? Was anyone going faster than 55.5 miles per hour? Yes. The car going 100 miles per hour. If we had went with the original numbers, would we have had any outliers? No. Alright. Is this okay with everybody? So this is really the end of section 4. Kind of a break.
One section. Is section 1?
No. Alright. So the final thing we're talking about is a box plot, which you guys have probably done before. Proxilisters. They're looking at me like I'm crazy, so I guess not. Alright. So it might be new. But the things that we're plotting are not. First thing we want to talk about is the 5-number summary. If you're going to make a box plot, you need a 5-number summary, and this is on your formula sheet as well. So the 5 things you need, and usually we don't label what they are, we just put the 5 numbers in order. So it's your minimum value of your set of data. So the smallest point in your data. Quartile 1, median, which is the same thing as quartile 2, quartile 3, and the maximum. So all things that we have found, quartiles we were doing in the last section, 5-number summary, max and min along with all those quartiles. We use these 5 numbers to draw a box and whisker plot. So when you have a box plot, it's going to look something like this. So it'll be a rectangular box. There'll be a line in it somewhere. We have lines going out. Okay. The box begins at your quartile 1. So where I begin my box is my quartile 1. The line in the middle is my median or my quartile 2. The line at the end is my quartile 3. The whiskers extend to the maximum and minimum points that are not outliers. How do we find outliers? Upper and lower fence. So if something is an outlier, even though that would be my minimum point, this will go to the smallest point that is not an outlier. So it may not be the actual minimum of our set, just the smallest one that is not an outlier. And same thing for the max. Then outliers are marked with an asterisk. So we might have something like this, which would show me I have a couple outliers out there. Let's So every 6 months, the Federal Reserve Board conducts a survey of credit card plans in the U.S. The data gives us the interest rates charged by 10 credit card issuers randomly selected for July 2005. Give the 5-number summary. So if I wanted to do this by hand, what would I have to do to my data first? Put it in order, small to large. So it looks like my lowest would be 6.5. Then we're going to have to be able to find all of our quartiles. So when we did that yesterday, I told you it's easiest to start with the median. We have 10 here. So my median would be in the middle of these two. So if you add those up and divide by 2, you get so if that's the middle, quartile 1 is the middle of the bottom half, so there's 5 points below, so the middle, that would be my quartile 1. And then the upper half, you get there. So my 5-number summary. We just list the numbers. So what is our minimum point? 6.5, comma, our quartile 1 was 12, median 13.6, quartile 3, 14.4, and then we end with our max, 14.5. Okay, you can label what's what, but there's really no need as long as you put them in order. Then we know what they stand for. If I asked you to draw a box plot for this, the first thing we have to do is find any outliers. So to find outliers, we need the upper and lower fence. So our lower fence is quartile 1, which was 12, minus 1.5 times the inner quartile range. How do we find the inner quartile range? So 14.4 minus 12 gives us 2.4. So my lower fence is 8.4. My upper fence is quartile 3, which was 14.4, plus 1.5 times the inner quartile range. And that gives us 18. So, outliers. Anything smaller than the lower fence or bigger than the upper fence. So what are my outliers in this data? 6.5, and that's the only one. Then if we want to draw our box plot, you have to put a scale underneath. You can't just have a random box floating out in the middle of nowhere. We kind of need to know what our numbers represent. So kind of looking at your 5-number summary, our smallest was 6.5, our biggest was 14.5, so we can make our scale appropriately. You don't necessarily have to start at 0, so maybe I'm going to start at 6, or at 5. And you don't have to label every number. just so, as long as I can see where your graph is beginning. So if we draw the box itself, the beginning of that rectangular box starts at 12 because that was my quartile 1. It ends at quartile 3, which was 14.4. And then you draw a line in the middle for your median or your second quartile, which was 13.6. Okay, the whiskers go down to the maximum and minimum value as long as they are not outliers. So I know 6.5 is an outlier. So my line goes down to the smallest point that is not an outlier, which would be 9.9. And then my maximum point was 14.5, and that was not an outlier. So that one's okay. Just barely there. And then what's the last thing I put on here? So at 6.5, an outlier, so we mark that. Alright. You can also tell something about the spread of your data by looking at that. You know, your median is like your middle. If we look, we have one whisker going way to the left, and we have another point down to the left. So what do you think that tells us about our graph? Skewed to the left. Symmetric data, your whiskers are going to be about the same length. Your median will be pretty close to the center of your box. So the closer that is to the middle and the more symmetric the sides look, the more bell-shaped our original data. Any questions on that one? Okay. I wanted to end just by showing you how we could do this on our calculator. And I told you you didn't have to bring your book, but I wanted to do an example out of the book. So I'm going to put one up here. Really just so we have some data to look at. Oh, that's not. Okay. So this example is talking about rats that were sent to space. And they wanted to see, somewhat blurry, but, so they were measuring the red blood cell mass of the rats when they returned from space. The control group did not go to space, but then the flight group did. And so they're just trying to see if there was a difference in the red blood cell mass between the two groups. So if I wanted to compare them, one way to do it is by using a box plot. We can put this on our calculator. And what you need to do is enter the flight group in one list and the control group in another. So, let's see. Can you guys read those okay? If you go into your stat plot, go into plot number 1. I want to turn that on. So there are two different options that kind of look like a box and whisker, but you'll notice the first one has dots next to it and the second one doesn't. The first one is what we want. That one will put the asterisk for any outliers. The second one will not. Okay, so should look like a box and whisker with a few dots. XList is my first one, and that's all I need there. I'm going to go ahead and have it do both of them at the same time. Did everybody get this one set up?
I know you want to get there.
Second, and then the y equals. Just like when we were doing histograms.
And then you turn it to the box thing.
You'll have to turn it on.
Oh.
And then we want that one first.
This one?
There we go. I'm assuming it's a test. Yeah. Oh my gosh.
I don't know if you saw that with the fear in my eyes.
I know, you looked terrified for a second. Did you get it? The one with the dots next to it.
That's not funny.
Okay. Did everybody get that? So that's my first plot. I'm going to turn on the second one as well, so I'm just going over to plot 2, or you can do second your y equals again. So plot 2 I want to turn on. Same thing, that first box and whisker with the dots next to it. But the difference, my X list this time is going to be list 2, so that we can look at both of them at the same time. How do you choose your first font? You do second, number 2. Oh, okay, so it's 2. Oh, thank you. Did everybody get that? Okay. So then if we go to zoom, number 9, it will just zoom automatically to where our data is. Oh, mine has another random line I didn't clear out of my calculator. Okay. So then we can see both of those. So let's see what kind of comparison we can make. On this, my blue one was my first set of data, which was the flight group. And the red one was my second set of data, which was my control group. So what do you think? Is there a difference in the red blood cell mass between the two groups?
Yes.
Yeah, it kind of looks like it. The flight group, what happened to the red blood cell mass?
Which one did you say was it?
The top one, the blue one, was the flight group, the ones that went to space. So how are they different?
Less.
Yeah, it went down. It's less. Now we can see a little bit like the maximum values, there's not really that much of a difference, but the median, the quartiles, all of that is significantly lower in that group. Do you think, are these skewed sets? Yeah, they don't really look like they would be bell-shaped, so we do have some concerns there, but then you can easily compare them and see, does it look to be about the same or not? All right, any questions on that one? So that is really the end of this section. I do want to just look at one problem here. I want to show you a couple graphs. I told you the box plots can kind of help us see if our data is skewed. But let's just compare a few and see if you guys can recognize how it's skewed. So if I look at this set of data, so this box plot, does that look like it is bell-shaped, skewed left, or skewed right? Skewed right. The tail extends really far to the right, so there are more high points than low points in that data set. All right, this one. So X, is that skewed left, skewed right, or bell-shaped? Bell-shaped. We can see the median is about the middle of the box. The whiskers are about the same length. What about the second one? Is it skewed left, skewed right, or bell-shaped? Skewed right. Why do you say that? Yeah, though we have a longer tail going to the right. So you guys can tell if it's skewed from this? All right, so that is my stopping point, and we are now really done with chapter 3. So you have the handout for 3.4 that I gave you yesterday, and I also have a handout for 3.5. We've got some time right now. Tomorrow, I'm not going to teach anything new, but I will give you class time to work, and then I'll probably also do some review problems because I want to do a quiz over this chapter on Friday before we hit the